Continuing with topic 4, oscillations and simple harmonic motion, we'll now move into section 4.2, which is about energy changes during simple harmonic motion. More so talking about mechanical energy, which are two forms of mechanical energy, or kinetic energy and potential energy. Just a little review: kinetic energy, energy of motion; potential energy, stored energy. GPE, gravitational potential energy, is more so going to be applied to pendulums, whereas EPE, elastic potential energy, is going to be applied to mass spring systems. So looking at this, energy changes while a pendulum is swinging. Agreed, right? You pull it back to some position, it's at rest, it's stored all that energy, you leave go, it swings faster, faster, faster. It should be the fastest at its equilibrium position, moves over to the other side, slows down, comes to rest, quote unquote, velocity equaling to 0. Therefore, at the greatest height, your GPE would be the greatest, your KE would be the least, etc., etc. So from this, what I want you to look at is, we have velocity here. So the equation that we're looking at is velocity equals your angular frequency times the square root of maximum displacement minus the displacement. Remember, your kinetic energy is simply KE equals 1/2 mv squared. So you're going to apply that in for B. So therefore, what we're really going to look at is 1/2 m angular frequency squared times xo squared minus x squared. Obviously, you're just able to get rid of the square root when you square something. So KE is max at the bottom of the swing because your displacement is equal to 0 meters. Okay, that's the highest velocity. Therefore, your equation for KE max is going to be 1/2 m w squared times xo squared. Okay, because the x was equal to 0, therefore it's not there anymore. Makes sense? So you're going to be able to simplify that equation. So at this point, at your KE max point, okay, when you're moving the fastest, your potential energy is going to be 0 joules. Okay, 0 joules at that point. So your total energy is simply going to be your kinetic energy plus your potential energy, a little bit more specific, whichever form of energy it is. In other words, your kinetic energy is going to be 1/2 m angular frequency squared, maximum displacement squared, plus 0, right? At the bottom of the swing, it's moving the fastest, so your PE is 0 joules. You can see that now. So plus 0, your KE, you don't have your x squared on there because that was equivalent to 0. So total energy must be constant throughout this system. Why? Because no work is being done. And not to get too far into that, but think about, or apply this to, the conservation of energy, like the law of the conservation of energy. So therefore, ultimately, the total kinetic energy. So ultimately, KE total is going to equal 1/2 m w squared x sub o squared. That's really what you need to get off of these previous two slides. So now let's move our conversation over to potential energy. So potential energy at any moment is going to be total energy minus your kinetic energy. This means that PE is going to be total energy, you just got it from the previous slide, 1/2 m w squared x sub o squared minus 1/2 m w squared xo squared minus x squared. You don't know if you're at your maximum displacement, so you don't technically want to get rid of that x squared yet. So therefore, ultimately, PE simply equals 1/2 m w squared x squared. See the difference? X sub o for kinetic energy and x for potential energy. So kind of look for those little helpful hints there, guys. So with kinetic energy, what you're looking at here is 1/2 mv squared is going to become 1/2 m vo squared sine squared wt. Okay, keep that in mind with this scenario. We'll look and dig deeper into these later on. So with the potential energy here, I already put the equation up in here for you. But what I really want you to get out of this is this portion right here. PE equals 1/2 mVO squared cosine squared WT. That's really what I want you to look at, okay? Make sure that you are getting this. Maximum displacement, and when you would have your 0. So your total energy here this is where you're going to first start to see your interference and how the total energy is going to be conserved throughout here. Because your potential energy is right there, and your kinetic energy is that line right there. So you can see at points where your kinetic is max, your potential is the lowest. So they're going to cancel each other out. So this is where we're going to start talking about in phase and out of phase, hence conservation of energy here, because whatever the KE is, it 100% transferred over to PE, and then vice versa. So an example of this problem says a pendulum bob of a mass of 200 grams is oscillating with an amplitude of 3.00 centimeters and a frequency of 0.500 hertz. Calculate how much KE the bob will have as it passes through the origin. So what we know going into this is a mass of 200 grams, which is going to be 0.200 kilograms. And you have your amplitude of 3.00 centimeters, which is really 0.0300 meters. And you have a frequency of 0.500 hertz. Yay, doesn't need to be converted. So you're going to ultimately calculate your KE max, measured in joules. So this equation that we want to use here, K equals 1/2 mv squared. Well, your V, when you're talking about your max, let me write this as well. Your V, when you're talking about at the max, is going to be W squared x of O squared. So really the equation we want to use is KE equals 1/2 m W squared x of O squared. Make sense? Okay? So all you're doing is just replacing in there. We got one more thing we want to replace. 2 pi f squared x of O squared. Because you don't know what your angular frequency is just by looking at your givens. You would need to calculate that. Furthermore, this is going to be your x of O. Agreed? Your amplitude is your x of O. It's the maximum displacement. That's by definition what amplitude is anyways. So your math is 1/2 0.200 times 2 pi 0.500 squared times 0.03, and I'm just going to shorthand that because I'm running out of room, squared. So once again, 2 times 0.5 is 1, 1 squared is 1, so you got pi squared there. So what we're really working with is 1/2 times 0.200 times pi squared times 0.0300 squared. Putting that into your calculator, please check that out and see if you guys are getting the same thing, okay? So once you get that, then you can say that your KE max is 8 let's check out sig figs, 1, 2, 3, 1, 2, 3, 1, 2, 3, 8.87 times 10 to the -4 joules. That's what your maximum kinetic energy is going to be at that point. So now what I would like you to do is solve through these 6 problems on a separate sheet of paper, please. Solve through these 6 problems on a separate sheet of paper. Ugh, hard to say. And we will look at them tomorrow during class, guys. That is all.